Since 1991, I've heated part of my home with wood burned in a masonry heater, but rising energy costs have prompted me to want to cover all of my heating needs with firewood and not just part of them. The chance to heat my 3,000 square foot home, both levels of my workshop, and all the domestic hot water that my family of 7 uses is what made me install an outdoor wood boiler at my place. This video covers how the technology works, why I chose the model that I did, and some installation tricks that you might find useful at your place. All outdoor wood boilers look like small metal garden sheds. A fire inside the unit heats water in an internal tank. That water is then circulated to neighboring buildings, where it delivers its heat energy for space heating and domestic hot water production. That hot water can be used in radiators, in-floor heating networks, or run through the plenum of a forced air furnace to deliver that heat through heating ducts. In the case of my own house, I've just retrofitted it with hydronic in-floor heating lines and antique cast iron rads because I didn't build the place originally with heating ducts of any kind. Now, at first glance, you might think that this sort of arrangement loses a lot of heat to the surrounding air and soil, but that's not the case if things are installed and designed correctly. For instance, my own boiler running at 180 degree Fahrenheit water temperature, that's about 80 degrees Celsius, when outdoor winter temperatures were minus 15 degrees Fahrenheit or minus 25 degrees Celsius, the heat loss from the unit was only about half a degree per hour. Now this shows that the insulation around the unit is certainly doing its job. When I first started researching outdoor wood boilers, I wondered why I didn't see more of them insulated with spray foam. I eventually discovered that since foam doesn't breathe all that well, it can trap moisture against metal parts and encourage corrosion. I also discovered that after long-term exposure to high temperatures, some kinds of foam can lose their insulating properties. All of this is why some kind of mineral batt insulation is an excellent option for insulating outdoor boilers like this one. I spent about 2 years researching the options, and in the end, I bought a Portage & Main Optimizer 250 model. Now, different manufacturers call these units different things. My favorite term is outdoor wood boiler. Some outfits call them outdoor wood furnaces or water furnaces. Now, as much as I like these things, I really have to admit that they're not for everyone. But if you live in a place where firewood is available, and you don't mind the work of preparing firewood and stoking the boiler, then I think they're a great option. They move the ash and danger of burning wood outdoors, and they also have a large firebox, so they let you burn big wood, which is easier to prepare than smaller stuff. I probably would have installed an outdoor wood boiler at my place a long time ago, except for the fact that traditional models create a lot of pollution and smoke. I made a really huge amount of smoke too. That's why some jurisdictions in North America have actually outlawed these traditional models. What changed my mind was the appearance of gasification outdoor wood boilers. These are approved by the EPA to put out at least 90% less smoke and pollution than traditional models. They also extract a lot more heat from a given amount of wood. Now, I'm going to show you exactly why I like gasification so well and how it works later on in this video. Another issue to consider as you plan and install your outdoor boiler is the possibility of heat loss through the underground pipes that travel from your boiler to your buildings. This is where a lot of people mess up, using pipes that lose heat in hidden ways. But it doesn't have to be this way for you. The 150 feet of Eurocon PEX Flex pipe that I installed from my boiler to my workshop, for instance, loses only about half a degree as it travels that distance, as measured with this infrared thermometer. I used pipe with a 1-inch inner diameter, which delivers better flow and more heat than the 3/4-inch diameter pipe that's sometimes used for residential installations. I'm a stickler for craftsmanship and details, and that's one big reason why I chose to buy a Portage & Main boiler for my place. One of the first things that struck me was the precision of the laser cut parts that you see on this unit. Another thing I really liked was the double welded joints inside the boiler itself. This means that both sides of each joint have a weld bead. This makes for smoother, stronger construction, but it also eliminates gaps and cracks where corrosion might ordinarily start. Now, when I first began researching outdoor boilers, I just assumed that a stainless steel design would be superior. But my research kept showing me that stainless steel can crack under certain boiler conditions. So the Portage and Main boiler is made of mild steel. Now, you might think that corrosion would be a problem with a material like this, but that's not the case. It's very easy to keep water chemistry in balance, so corrosion is simply not an issue. I also especially like the heavy-duty adjustable door latch mechanism and the steel-reinforced refractory lining on the inside of some of the doors. There's one other thing that clinched my decision to go with Portage and Main. Portage and Main boilers are made by a faith-based community in rural Western Canada working together in their own high-tech facility. These people value honesty, hard work, and attention to detail, and this really counts for a lot in my book. They're also constantly updating and refining the design of the boilers they build to make the most of reliability and performance. I also found the salespeople to be mechanically minded and quick to answer any questions I had about the boiler, both before and after I bought it. Regardless of the boiler you choose, you're going to have to build a concrete pad to support the unit. Here at my place, I dug down 10 inches, laid down some compacted crushed gravel, and then a layer of fiberglass rebar to hold the fiber-reinforced concrete together and eliminate any cracking. Now, my pad has a notch at the back, and that's to allow pipes to come up into the furnace from down below. This is a lot easier to build than the usual method of putting the pipes through holes in the pad, and it also allows me some flexibility. I can add another line leading from the boiler later if I want to. Now, when it came time to set the furnace in place on the pad, I had a friend of mine with a big loader tractor do the work. At this stage, the pipes are already set into the notch and buried, ready to make the connection to the furnace. Installing an outdoor boiler is a lot of work. There's no question about that. But having done the job myself, I can tell you that the work is within the capabilities of any moderately handy person. Now, you can certainly hire a professional to do the job, but one of the advantages of doing the work yourself is the satisfaction you get from it. That was certainly the case with me, as you can see here on the first lighting of my boiler. Well, it's a historic moment. In the next little while, I'm going to be firing up my outdoor wood furnace for the first time. I've spent the last few weeks digging trenches and making a mess of the lawn and laying pipes and hooking those pipes up to panels on the one end, radiant in-floor heating panels on the one end, and the furnace on this end, and working with steel pipe and plastic pipe and a little bit of electricity, and now we're all ready to bring it together. I'm just stoking things up here, and we'll light this newspaper and cardboard and wood on fire in the next few minutes. When the guy who works at the little country hardware store where I buy my stuff heard that I'd bought an outdoor wood boiler, he wondered why. I mean, don't those things burn a rainforest worth of wood each year? He asked. Well, the fact is, outdoor wood boilers can consume a lot of wood depending on the design. The difference between an efficient and an inefficient model is the difference between burning, say, 15 face cords of wood a year and 30 to heat the same space. My research showed that frugal operation boils down to something called a Firetube boiler design. Multiple hollow steel tubes run through the water tank, and exhaust gases travel through these on their way out to the chimney. Now, this design extracts large amounts of heat from the combustion gases on their way out, and it's one of the biggest reasons why I chose a Portage and Main unit for my own home. The Firetube boiler design that's used in my outdoor wood furnace originates from an idea that was invented way back in 1804. It was an enduring part of marine and stationary steam engines at the time, and it's even used in the best and most efficient boilers of today. On the Portage and Main unit, there are 20 horizontal tubes which pass through the water tank itself. This is for exhaust gases as they leave the firebox and travel towards the chimney. There are also 6 more vertical tubes leading from the gasification chamber down below. All in all, this adds up to almost 100 feet of heat transfer area for extracting heat from the exhaust gases on its way out. Many of the other outdoor boiler brands I investigated before choosing this one use little or even no fire tubes at all, relying mostly on the inside of the firebox to transmit the heat from the fire itself to the surrounding water. The only drawback with the fire tube design is the need to clean fly ash from the inside of the tubes every week or two. This is done by running a round brush on the end of a pole through the tubes, knocking the fly ash off. In the case of the portage and main design, there's hinged doors at both ends of the tube assembly, so it's easy to remove that fly ash once you've knocked it loose. Few people realize how wood gasification works or how impressive it is to see firsthand. In the case of my wood boiler, a fire is lit in the main firebox and then the sealed door is closed. Air is admitted to the fire through a small electric fan. This supports combustion of the wood itself. But the only place for the smoke and gases to leave is at the bottom of the firebox, through a thin slot in the refractory material. This action compresses the gases and causes them to burn a second time at high temperature in the gasification reaction chamber underneath the firebox. Earlier designs of my boiler had the combustion air admitted near the bottom of the firebox, but more recent models have that air piped in near the top and the back for cleaner combustion. Air is admitted through 22 5/8-inch diameter holes, so it reaches all of the combustion over the whole area of the firebox. This air is supplied by an air box assembly at the back of the unit. There's a small electric fan motor in there. It's got ball bearings, not bushings, and those bearings are sealed to protect them against dirt, to make them as reliable as possible. There's also 2 air dampeners that close when the fan stops blowing air into the firebox. A small electric motor that controls these dampers is widely available should you ever need to get a replacement. A unique feature of the boiler I have is the use of a lot of refractory material in the bottom of the firebox and the reaction chamber. And besides lasting a long time, there's a good reason for this. There's 5 inches of refractory material that forms the bottom of the firebox and 4 inches that forms the bottom of the reaction chamber. This retains heat, and it means that the gasification process kicks in a very short time after the fan motor starts up as the aquastat calls for more heat. Most of what you see coming out of the chimney on a cold day isn't smoke, but actually white steam. It's the moisture from in the wood condensing as it makes its way out of the chimney. Now, all outdoor boilers use an aquastat of some kind to control the water temperature in the water tank. The aquastat turns the fan on or off depending on whether additional heat is needed in the water. They let you set the maximum temperature that the water will be. Now, the portage and main unit that I have comes with Johnson brand aquastat controls. These have proven reliable for many years in the industry. They're widely available and economical if you ever have to replace them. Fitting together threaded steel pipe connections was a part of my boiler installation, and I originally used Teflon tape and ordinary pipe compound to seal those threads. Unfortunately, a number of those connections leaked, and that means I had to take everything apart and start all over again in some places. I ended up switching to an automotive thread sealing product, and it worked really well. It was fast and perfectly effective. Now, this little bottle costs $40, but I'll tell you, it's well worth it. Don't skimp when it comes to sealing any pipe thread connections in your installation. Regardless of how you make your pipe connections, I strongly recommend that you pressure test everything with air before you add water to the system. It's just a whole lot easier to make repairs if there are any leaks beforehand. Now here you can see the gauges and fittings that I put together to allow me to pump compressed air into the pipes and then watch the gauge pressure. The slightest leak will cause that gauge to go down, so it's easy to spot if there are any problems. Now, no matter how efficient wood heating equipment is, it's still a lot more physical work than dialing up a thermostat and keeping warm in the usual sort of modern way. But if you stop for a minute and you think of all the time and hassle you've got to invest earning after-tax dollars to pay for heat in the usual way with electricity or propane or oil, then wood heating starts to look a whole lot more attractive. And if you're anything like me and you value the chance to exercise in the fresh air, cutting, splitting, stacking wood, and stoking an outdoor boiler, then maybe this method of heating is for you. I know it certainly is a great thing for me.